All right, so we're going to go through some examples of using the laws of exponents to simplify equivalent or write equivalent expressions for some examples here. All right, so let's say we have something like 4.5 squared, and that quantity is to the fifth. All right, we're not solving it, we're just going to write an equivalent expression. Well, this is a power to the power, right? So we're going to be just taking this 4.5, and this is equivalent to this exponent times that exponent. So this is 4.5 to the 2 times 5. Right, so when the exponent's raised to an exponent, you multiply the exponents, which equals 4.5 to the 10th. Okay, so that's power to the powers. All right, here is a 3/7 raised to the negative third. All right, so there's two things that you got to do here. The first one is you got to deal with this negative sign. When you have a negative sign, it inverts the exponent. So it turns it into 7/3, and you still have it to the third. And now you have this to the third, it's going to yield that 3 is going to be distributed to both the numerator and the denominator, yielding 7 cubed divided by 3 cubed. That's the equivalent expression. All right, now we have a negative 2 times 6 to this quantity to the fourth. Right, so this means that this 4 is distributed to both the negative 2 and the 6. Now you could multiply these two together and raise it to the fourth, or you could take negative 2, raise it to the fourth power, and multiply it to 6, raised to the fourth power. That is a product raised to a power rule. All right, so here's a negative 3.1 raised to the 10th, divided by a negative 3.1 raised to the third. These are the same base, so you have a same base with different exponents, one divided by the other. So this equivalent is negative 3.1, 10 minus 3. When they're divided by each other, you subtract the exponents, yielding negative 3.1 to the 7th. All right, and then here we go. Finally, we have a -4. Then you have a times a 7 times a 3. All right, so it's 7 times -4 times a 7 times a 3. Oops, sorry, 7 to the third. Excuse me, 7 to the third. Okay. Well, what is not shown here is that this is a 7 to the first. Right. If the exponent is blank over a base, it's to the first power. Because remember, anything raised to the first power is itself. Right, so you're going to add these exponents. So this is going to be equal to 7 to the -4 plus 1 plus 3. Right, 4 plus 1 is 3. Oh, sorry, 4 plus 3 is 4. Plus -4 equals 7 to the 0th, and anything raised to the 0th power equals 1. All right, so there's that one. Okay, so now we have some radicals. Right? So when we have something inside of a radical, like 64 to the here, right? This is to the first power. Okay, so when you have something inside of a radical, it's the same thing as this becomes the numerator, and this becomes the denominator. So this is 64 to the third. All right, so there's that. All right, so this is square root of 64. So this is a 1, this is a 2. All right, so this becomes 64 to the 1/2. Okay, so there you go. If there's anything else here. All right, so here we have a square root of y times the square root of y. And we're going to try to figure out, well, how do I do this? Okay, let's say I can change the square root of y times the square root of y is, well, that's just equal the square root of y squared, right? Well, quantity squared which equals y. Right? Another way to look at that is, well, this is y 1/2 to the 1/2 times y to the 1/2, which yields y to the 1/2 plus 1/2, which equals y to the first, which equals y. Right? So that's one way to look at it. So there's that. That's pretty much all I wanted to talk about for these things. That pretty much sums up, most of them. There's a lot more, but you just need to know them and exercise them in order to use them. Hope that helps.